This video is going to cover factoring the difference of perfect squares, or what we call a difference of squares. This is actually one of the easiest types of expressions to factor, as long as you can identify the squares, the perfect squares, which is what we're going to use. You can factor these relatively quickly. If you remember, these are quadratics. Now, quadratics are in the form ax squared plus bx plus c. That's standard form, and usually that's equal to f of x or y or whatever notation you want to use the function for. And we've been doing the AC method and factoring trinomials, but what if we have a binomial? And binomials have specific characteristics. Well, these particular binomials are what we call differences of perfect squares, or just difference of squares. Difference meaning subtraction, so that means that you're going to subtract, and squares meaning they're perfect squares. Now, if you recall, here are perfect squares: 1, 4, 9, 16, 25, 36. You get the idea. Perfect squares are when we can take a number, a whole number, and square it and have the program go absolutely crazy. Square it and get a number. Those numbers are called perfect squares because they have square roots. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6, and so on. You've seen this before. Now, when we look at variables, let's say we're looking at x squared. X squared is a perfect square because the square root of x squared is x. B squared is a perfect square because the square root of b squared is b. Those are also perfect squares. So perfect squares can actually exist as variables as well. So let's look at the first one. And I'm going to show you a very quick way to factor these. When we have a difference of squares, it follows a pattern. And here's the pattern. When you have two numbers, a squared minus b squared, in that format, the way you factor it is a plus b, a minus b. You don't have to go through the AC method. It's a difference of perfect squares, so we can actually take a shortcut. So the first thing we have to do, the most critical part, is we have to establish, do we have a difference, meaning a subtraction, of two different perfect squares? Well, let's look at number 1. Let's take a look here at this guy. Well, I have x squared. That itself is a perfect square. I have my required difference. So the question is 25 a perfect square? And actually, it is. I can rewrite this as x squared minus 5 squared, and I have two perfect squares. So when I write the factors, I'm just going to take each of my perfect squares and split them, x and x, 5 and 5, and then one's addition, one's subtraction. Done. That's it. That is how you do a difference of two squares and factor it. You don't have to go through the AC method or grouping or anything else. You can take a shortcut, as long, again, as it's a difference, a subtraction of two perfect squares. Let's look at number 2. Number 2 is x squared. That is a perfect square. Minus 9. 9 is a perfect square. It is actually, in fact, 3 squared. So since I have a difference of two perfect squares, I can factor it by splitting x and x, 3 and 3, plus and minus, and we are done. Difference of squares are actually very nice. Once you can identify them, they're very easy to factor. The key part, again, is just identifying whether or not you have perfect squares. Let's do one more. So let's look at number 4. Number 4, I have x squared And I have 49. Is 49 a perfect square? Yes, it is. It is 7 squared. And I have my subtraction. So this is a difference of two perfect squares. So once again, I'm going to split them, x and x. I'm going to split the 49 into 7 and 7. And one is addition, one is plus, one is minus. All done. So this is how you can factor a difference of two squares. Well, what happens if we don't have a lead coefficient of 1? What if it's not a 1x? What if it is something like number 6? So let me erase this and get this out of the way here. And let's check out number 6. Number 6, I have 9x squared minus 16. Well, let's look at the components. Do I have a difference? Yes, I do. So the difference component is met. And then let's work backwards here. Is 16 a perfect square? Yes, it is. It is 4 squared. So far, so good. But let's look at the lead term now. I've got 9x squared. I don't just have x. I have 9x squared. Well, obviously, x squared is a perfect square, but is 9 a perfect square? 9 is a perfect square. So I actually can rewrite 9 as 3 squared. So my lead term, or my first term, 9x squared, is actually 3 squared times x squared. And when I rewrite that, I can actually combine the two, since they're both squared, and write it like this. Now I'm ready to use my factoring. I'm going to split the 3x and the 3x. I'm going to split the 4 and the 4. One's positive, one's negative, and you are done. This is where most people struggle, is when it's not a simple one like 1, 2, or 4, and you don't have a 1 as your lead term. Let's check out number 8. Let's look at this one right here. I'm going to do it above so that I don't have to move my screen. Well, first of all, I've got 9. 9 is a perfect square. It's 3 squared. So I can write it that way. I do have a difference. I have my subtraction. That's met. So what do I do with 64x squared? Well, 64 is a perfect square. That's the same thing as 8 squared. So basically, I have 8 squared times x squared. Well, when I rewrite that, that's the same thing. I'm going to write it up here as 8x squared minus 3 squared. Now I can do my factors, and I apologize for writing it a little bit out of order here. I'm kind of working up instead of working down, just for space purposes. So I'm going to split my 8x and my 8x. I'm going to split my 3 and my 3, and then I have my positive and my negative, and it's complete. So that is how you factor a difference of two squares, and it has to be a difference. If I have something like x squared, if I have x squared plus 9, that is not a difference of squares. Why not? Oh, why not? My screen just decided to move. Apologies. Let's put this back. Why can I not do that? Well, I can't do that because that is not a difference. That is a sum. We don't factor a sum of two squares. We factor the difference. So that is what we're looking at when we're doing a difference of two squares. Perfect squares on both ends, no b term. Notice that the b term is missing. In this one, I have no b term. This is subtraction. It's a negative, and both c and ax are perfect squares. And that's how you do difference of squares.